Well, welcome to a short primer on using the right-hand rule. Your right hand. You have to know the right from the left or you're going to get it mixed up. But if once you got that, it should be a piece of cake. So if we have a current running through a wire, we want to often find out what is the magnetic field around it. It is very simple. You put your thumb in the direction of the current flow. It should be given in the problem or you'll have to figure it out. But the thumb goes in the direction of the current, and then you curl your hands. Now I'm going to go over to this side. They would curl like this. Okay, so in the plane, I'll go on the board here and show you. Why don't I do that? Okay, right up here, I have a wire going horizontally. The current is going from left to right. So I'm going to put my thumb like I'm hitchhiking, but turned a little bit. You see how my hand goes? It's indicating that the magnetic field comes up and out like that and goes back around. It's coming around like this. Okay, so at the top in this plane of the board, it would be coming out right here and it would be going in right there into the plane of the board. So right at this point here, we often talk in two dimensions in our problems. All right. Likewise here, the current is going down. I would put my thumb down. So right on this side of it, it is going into the board and it is coming out here. Okay, and they are circles that go around. Okay, the further you get away from the wire, the less the magnetic field is, obviously, and we have an equation for that. But I want to really just point out today the direction of the current. So of the magnetic field line. So use your right hand. Hope that helps. Okay, well now continuing on with the right hand rule. Now take your right hand. All right, we want to look at three orthogonal or perpendicular planes. Sort of like the corner of a room. Okay, you all have a right hand. Pull this. Okay, your index finger, your pointing finger, your trigger finger, that shows the velocity of a positive charged particle. Okay, or the flow of current. Okay, your bad finger, all right, the middle finger, that is the B. That is the magnetic field. And your thumb, okay, that points up is the force, the magnetic force. So we would hold it like this. You can move it any way. We're going along with a way a positive test charge or a positive charge would move. So if you use that for a negative charge, say an electron, and it goes along, when you get the final answer, you just flip whichever your resultant answer is. If you're looking for the force, instead of it being up, it would be down. If you're looking for the B, in this case, instead of it being into the board or negative K direction, it really would be out. I've drawn a little picture on the board here. Hopefully you can see it. A little bigger hand, okay? Finger pointing out is the flow of positive current or plus Q times V. This is the charge. This is the velocity of the charge, of the positive charge particle. This finger here, your bad finger, you don't want to just use that finger by itself, okay? Pointing straight out from the board here, okay? That is the magnetic field. And finally, your thumb here indicates the direction of the force, the resultant magnetic force for a charged particle moving along with a velocity in that direction in a magnetic field that is perpendicular coming out of the board. Hope this helps you.